Hi, I'm Yeshwanth. I'm a graduate student in Northeastern University in Telecommunication Systems Management. As part of software-defined networking and NFU coursework, I'm supposed to do a project on SDN. So my prime focus of the project is monitoring an SDN controller using REST API services. So in this scenario, I have considered POX, and I have implemented REST API services on POX and written a basic monitoring application in Python, aligning with its own DB. So I'll navigate through the project. So this is the agenda of my presentation. So let's start with introduction. So this presentation mainly explains about how SDN controller and the switches connected, all the devices connected to the SDN controller can be monitored. So in this scenario, I have considered POX and I have implemented REST API services over POX. So the source code of POX has been thoroughly read, and REST API, and every component of the controller has been identified, and all the data structures has been analyzed, and wherever the data is stored. For example, if a traffic flows from one interface to other, so how the data is being passing through the controller, at what time we can fetch the data. All these things have been analyzed, and REST API services has been implemented. So the data, when the REST API call is done being using HTTP, so the data is being stored, the data is retrieved using a JSON format. So there is no particular reason why I have chosen only JSON. We can take XML, then we can take simple text format. So JSON gives a dictionary kind of feeling, so, and it's easy to grab data from the format. So, and this can be used for various network management and EMS and NMS services. And the requirements of this project are POX controller, Python, Mininet, Linux operating system, and VMware workstation. So the first question comes is why monitoring? So monitoring of any network equipment is very important. So we can't even see any downfall of any network equipment. So I would just explain that I would extend this definition by not only monitoring the network for outages, but also monitoring the performance. And the next question comes is why I have chosen RESTful web services for monitoring. So as we all know, general protocol which is used across all network devices for monitoring is SNMP. So SNMP has been in the network industry for from a long period, and SNMP is actually a difficult protocol to implement, and SNMP version 3 has its own complications. It has its own security features being implemented, and the reason SNMP has its own web structure. It is complicated if at all we want to implement for every protocol, for every device structure. So if at all you go on to a device class and you check the SNMP maps, it has its own tree, and it goes in detail. So the reason behind me choosing RESTful services is, so HTTP client. So it's a very simple program to implement. So implementing a HTTP client which queries a controller to get the necessary information, and nowadays almost all programming languages has their own HTTP client module. So, and RESTful services can be used. So when even as we have authentication in SNMP version 3, the same way HTTP client, we can use cookies, we can use sessions, we can use username for authentication. And this is the main reason. And HTTP is faster, so I have chosen HTTP for this. So the main reason is, as I have told, SNMP is traditional, but it's complicated, and there is no dependency on MIPS here. The scope of the project is to implement the RESTful web service on the northbound and the southbound interface. Northbound to get the application stats, and southbound to get the various open interface and open flow protocol stats. So once the RESTful services are implemented on the POX controller, the main idea is to develop a multi-processing monitoring application which talks to the switch, which talks to the various devices which are connected to the controller. So a basic monitoring application for now has been developed in Python, which fetches frequent data from the controller and retrieves in the form of JSON. And this data, the moment it is fetched from the controller, it is stored in a MySQL database. So I have used Python SQLite module for creating a database and storing the details. So once a request is done from the controller, the data is being collected in form of a JSON, and a kind of analysis, a data analysis has been done on the JSON retrieved data, and based on the stats required, I have stored it in a DB. So, and coming on to the high level architecture of my monitoring application. So here comes the controller, switches connected, and the devices. So my monitoring application lies on the top. It contacts communicately with the controller using the REST API services. So repeated HTTP requests are triggered onto the controller to retrieve its data. So it runs on, as we know that the POX controller runs on the TCP port 6633, and I have leveraged the services of port 8082 to implement the RESTful services. So whenever I trigger a RESTful services on this port on the controller's local host, a RESTful response has been retrieved. So this comes to the overall architecture of the monitoring application, and let's go in detail of the monitoring. I mean, how the application works, what are the components of the application. So let's think this is the SDN controller, and these are the 4 components of the application. So first is the user interface, which is just a graphical user interface, which is optional. So it's just to give a UI feel. Then the database it's only used to store the data. So you can have a user interface like phpMyAdmin to take a look on what are the contents of database, how the data is stored, what structure it is followed. And the main 2 components of the monitoring application are data collector and the message collector. So coming on to the data collector. Data collector is the component which performs repeated HTTP requests to the SDN controller, and so it collects data using REST API. And there is another when data collector is collecting the data. So what could be the reason of a message collector? So as we know, have you ever heard of traps in case of SNMP? So the main reason of having a message collector is to identify such kind of messages being sent from the device. I mean, automated messages sent from the device to the controller. So if at all some configuration changes, any alerts, immediate alerts need to be triggered from the controller. The data is being collected by the data controller, and all the messages traps are being collected by the message collector. So once the data is collected, the data is stored in the database, and a constant sync up is being done between the UI and the database. So this is the high level approach, and the data can be used for analytics and for event management services to generate alarms to notify the network admins. So this is the high level architecture of the monitoring application. So just to go on a high level view of the REST API services which I have written in Python. So mainly I have used a micro framework which is for a micro framework which is a simple HTTP client server used to generate RESTful services. So this is the draft code of what I have implemented. So this is, as you can see on the top, it is for switches to get the data of the switch. So it gives different details like string ID, so what port the switch is connected to, and what is the switch ID. So in the same way, I have implemented for flow stats, queue stats, so aggregation stats, so n number of stats. As we can scale up the product, it could go to the end. So right now I have implemented for 4 to 5 concepts, and this is the simple monitoring application code which I have written in Python, where it triggers repeated HTTP request, as you could see on 8082. So, so just to give a small example, on the top, the switch DPID. So I have extracted the DPID, stored in the DB, based on particular DPID of per switch, repeated requests are being triggered, and the data is being collected. So right now my collection time is 1 second, and in the same way, at the same time, when the data is being collected, as you can see, there's an insert command to store in the DB. So before that, you have just seen the code format. So if at all we trigger the RESTful services using our browser. So as the controller works on the local host, I have local host, then port number. So just the URL. So data model can be created. On what API URLs this particular data can be achieved. So this gives the switch stats, port stats. So what number of packets being dropped, number of packets. As you can see, the transaction packets are 33. Then after some time, when I trigger the same request, they are 67. So this is how various kinds of details can be extracted, and based on our requirements, based on the customer's requirements, we can just store it in the database. So this is the Python application which I have written. So as you can see, I have just printed few of things because in the whole view it could be a little cumbersome. So as I have printed for every 1 second. As you can see on the top, RX packet 124, 126, 127. So it is a repeated request hitting the controller, getting the details. And this is a table format of the data being stored in the DB. So it's just to give a user what data is collected at what time. So this is being done. So the future scopes of the project, it can be implemented for various protocol statistics, and this same application can be used for multi-vendor controllers as well as normal, traditional legacy network devices too. So it doesn't stick to only SDN. It also can be used for normal SNMP monitoring application can be used for normal devices as well as SDN devices. And this particular monitoring application can be integrated with various analytics tools, and even if at all our data is in scale of a big data, so it can be integrated with tools like Splunk for big data analytics, and authentication and encryption between the API services can be performed. So these are the few references which I have primarily used, like Portal, Mininet. So I have created a Mininet topology and retrieve all the information between the hosts. So any questions for me?
Hi, my name is Ram and I have the following question. Can this be implemented in multiple controllers?
Yes. So as I have told, then the when the monitoring application is going on, a multi-threaded scenario can be, multi-process scenario can be created. So one based on the ID of the, for every controller, for every device being retrieved by the controller, by the monitoring application, an ID is being stored. So based on the ID, the data is being collected and it is stored. So every controller has its own specific ID, and there is no discrepancy. There is no chance of data being mismatched or mixing up between the controllers. So every device will be treated as its own, as its own. And if at all one device is having its child components, though they have their own device IDs, they'll be mapped to a parent ID, and that will be mapped to a parent ID, so that okay, this controller has these many child devices in that way. So it can be implemented in a multi-controller scenario too.
Hi, my name is Hari and I have following question. Can you explain how you implemented high availability in this project?
So as it's a monitoring application, high availability failover plays a major challenge. So as we can see that data collector and the database are the important aspects for the monitoring application. So these are active and we can maintain an active and standby state. So we'll have an standby database and a standby data collector. So once the main data collector fails over or the database fails over, the standby picks up, and we can have we can have regular snapshots from the database being stored in the standby database in order to achieve high availability in this scenario.